All right, welcome. In this video, we're going to talk about systems of linear inequalities. Now, last unit, we graphed linear inequalities, and earlier in this unit, we've been talking about systems of equations, and so we're going to kind of put those two together and talk about systems of inequalities. So we're going to have more than one shaded region. And so first, I'm going to remind you about how we shaded, or how we graphed our linear inequalities last unit. I think that was unit 1, lesson 4, something like that. So we're going to sketch the graph of y is greater than 2x minus 5, okay? And so we'd start off with the graph of y equals 2x minus 5, and we would graph that, right? And then we know that because y is less, I don't know if I said greater earlier, but y is less, we're going to shade the area where y is less, which is below. But because it's strictly less, we needed to have a dotted line. And so I'm going to come through here with an eraser and kind of remove some pieces of this line so that it looks a little more dotted. And then there we see how we've got a dotted line. And we're going to shade below it because that's the area where y is less. So I'm going to shade down here. And it's everything below here. Because, remember, and that's what's written down there in gray that I'm emphasizing, is that the solution to this inequality is the set of xy coordinates that satisfy the inequality. Let's talk about more than one now. Okay. So if I brought in like 3 inequalities or something, we could do this. We're just going to sketch all of the solution regions for these inequalities individually, and then we'll see where they all overlap, right? Because we're going to want to shade the xy pairs that satisfy all the inequalities in the system. But we'll get there. Let's start small, right? We'll start with y is greater than 2x minus 5. So I'll try to draw it the same way, about like that. Okay, we knew it needed to be a dotted line because of the strictly greater than, and we can make that happen. It doesn't need to be super dotted or anything, it just needs to not be solid, right? And so it's going to be above that. But I'll come back on that in a little bit, right? Because I don't want to have so much shading going on that I can't tell what's going on, right? So then I will graph the second one. And this one, I don't know, I might just go ahead and suggest that we solve for y in terms of x on this one. So 6y is less than or equal to x plus 12. And then I could divide everything by 6 and say y still less than or equal to, because I didn't divide by a negative number or anything. Negative 2 over 6 is negative 1/3 of x plus 12 divided by 6 is 2. Okay, so negative 1/3 x plus 2. So I don't know, maybe 2's here, and negative 1/3, that's pretty shallow slope. So, oh goodness, that was bad. I'll try that once again, and that'll have to do. That's as good as you're going to get from me here today. And then, okay, and then x is greater than or possibly equal to 1. Okay, well, x equals 1 probably about right here. Okay, because this was equal to 2 and this was negative 5 down here. So that's probably about 1 there. X equals 1 is all of the points that have that x coordinate, which kind of gives us a vertical line. And if x is less than or equal to 1, okay, then I'm to the left of that line. Okay, if y is less than or equal to, oh, pardon me, I meant to write this in. I'm to the left of that green line. If y is less than or equal to negative 1/3 x plus 2, I am beneath the red line. And if y is greater than 2x minus 5, then I'm going to be above the blue line. And so I would be talking about this region right here off to the far left, all of these points, including these and on down here, and then just all of the rest of it, right? And so it's a lot of points, right? But it's going to have, more shape to it than the ones last time where we just either shaded above or below. Okay, and so that's going to be our solution region. All right, now let's do some examples that have, I don't know, something else attached to them. So we're going to start by sketching the system, and then it's going to ask which quadrants contain solutions to the system. And I don't know if quadrant is something that we've talked about yet this year. So I'm going to either tell you for the first time or remind you that the quadrants, I might put these up towards the top. That this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, For instance, quadrant 3 is where x and y are both negative, and quadrant 2 is where x is negative and y is positive. Okay. Sometimes they use Roman numerals, sometimes they use regular numbers. So I'll just put those over here as well, right? And so, and I don't care if you use Roman numerals or regular numerals. It does not matter to me. I guess I just need you to be able to recognize both. Okay, so if we go over here and we're going to say, all right, x plus 2y is greater than 5. You know, I think I'm going to see. I haven't looked at this, so I haven't graphed this in a while. I actually delivered this lesson a few days ago. And so I haven't really I don't remember how this one's going to play out. So I'm going to solve for this one y in terms of x. I don't know if it actually matters. So 2y is greater than negative x plus 5. And y is greater than negative 1/2 x plus 5. And so maybe I should do the other one also so I know what my other y-intercept is and my other slope, so I have a better idea of what scale I want to use. Okay, so then I'll have 2y less than or equal to negative 3x minus 4. Then I'm going to divide everything by 2. Okay, so I'm going to have a positive slope and a negative slope and pretty shallow. Okay, I learned from my mistake last time trying to draw a line. I'm going to bring in a straight edge, and I'm going to give it, I don't know, I'm going to get pretty shallow. Looks like about negative 1/2 to me. I don't know. That'll have to do. And I know that this wants to be a dotted line because of the fact that it's a strict inequality. Yeah, that should be good. All right, and then I'll graph the other line, right? Negative 3/2 x minus 2. And so negative 2 is probably going to be like, you know, well, not as far as positive 5. Negative 3/2 x, well, that's going to be a little steeper. And so I know since that's less than or equal to, I can draw a solid line. I won't need to do any erasing. And there I've got myself that. I feel like depending on the directions of these inequalities, I might need a little more of this line. So I might, oh man, that was a little rough, but I extended it. All right, y is above the dotted line, because it's y is greater than right here. And y is below the solid line. Yeah, so that is going to be this region out here. So I would say that the only quadrant that contains solutions, because it's going to keep going that way, right? The only quadrant that's going to contain those solutions is going to be quadrant 2. Okay. All right, so this next example is kind of similar, but also with a little extra wrinkle at the end. What's the area of the solution region? So this one's going to probably be entirely enclosed, because it wouldn't be interesting for me to ask you for the area of an unbounded region, because that would just be infinite or something. Wouldn't even be an answer to it. So we're going to graph this system. And I think I might actually move this over here. Give myself a little more room to work. Okay. So y is greater than or equal to 3. Oh, well, then I'm going to really enlarge this thing. Yeah, and not look so much at the area where y is negative, right? We don't really need any area where y is negative if we're going to start off with y is greater than or equal to 3. So I saw that one, and I just kind of wanted to plot it. Okay, so I'm going to decide that this is 3 here. And that's y equals 3. So we're going to be above that blue line. I didn't realize I went off the screen. Oh my, that's way off. Okay, there we go. And give one of these. All right, x is between negative 4 and 6. Okay, well, I'm just going to decide that negative 4 is going to be over here, and 6 is going to be, maybe I could go a little farther there. Okay, x equals negative 4 is this vertical line here. You know, we could let it go down as well, but I don't care so much about that, because we only care about where y is greater than or equal to 3. And then, okay, I've got this, and if x is between these two, right, it's going to have to be this area in the middle, and I'm above 3, so I'm already kind of narrowing it down. I've got x plus y is less than or equal to 12. Okay, I'm going to decide that's my 12 here. And Well, it's going to have a negative slope, and I need to decide that 12 is happening lower. I can already tell that. I'm just going to need that to be 12, just for the sake of argument. Now, the x-intercept of this is going to also be x equals 12, so I don't need it to like go down and hit the x-axis or anything. I just need it to kind of go down a little out of sight here. There we go. That will be perfect. All right. So if y is less than or equal to 12 minus x, I'm below that slanted line, above the horizontal line, and between the two vertical lines. So I've got this region here. It's my solution region that I'm trying to find the area of. This is a trapezoid. Now, the problems on the homework and on the quiz and stuff, they'll probably be triangles, right? But I figured while we're together, it might be good for us to review the idea of the area of a trapezoid. And what we do to get that is that we're going to average the parallel sides and multiply by the length of the perpendicular side. So we've got some work ahead of us, right? We need to find the, say, probably the y-coordinates of these 2 points. And that'll be good because I know that the width of my base, right, along the bottom where y equals 3, that's going to be 6 minus negative 4 is going to be 10. So I know that I've got 10 here, got kind of 2 different side lengths here, and then it's connected. Okay, so I just need to figure out what's going on there. In order to find the y-coordinate at this point, I'm going to need to say, all right, this is the solution to the system x equals 4 and x plus y equals 12. Okay, this is probably best done with substitution. 4 plus y equals 12. Oh, y equals 8. So the length of that left side of the trapezoid is going to be not 8, but 8 minus 3, top minus bottom. So it's going to be 5. And then over here on this one, I need to find out what the y-coordinate is of this one. But this is, again, equivalent to solving the system x equals 6 and x plus y equals 12. So I think that's going to be where y is equal to 6. And that means that the right side, pardon me, didn't realize, I just need to shrink down, that the right side has a height of 3, not 6, because it's 6 minus 3, top minus bottom. Okay, now if we're tasked with finding the area of this region here, then, like I said before, we're going to average the parallel sides. So add them up and divide by 2, and then multiply by the height. Okay, and so that's going to be equal to half of 8 is 4 times 10 is 40. I don't remember if that's what we got. I worked this problem in class. It doesn't seem familiar. Let me check. Nope, it's definitely not, and that's what happens when I record these videos without an audience. This over here, this point on the left, this is not where x equals 4. This is where x is equal to negative 4, which means that y would need to equal 16. The left side would be 16 minus 3 is 13. Yeah, that's feeling a little more familiar. And then half of 13 plus 3 multiplied by 10, that's going to be 80, and that's, I think, more like what I remembered getting the first time. Okay, now that was a good selection of example problems. You know, this is the type of thing that we are assuming that you've done this before in Algebra 1, so it shouldn't be, shouldn't be as challenging as the 3x3 systems with elimination and substitution. Okay, all the same, you should practice these because we're going to ask questions at maybe a higher level than they asked in Algebra 1, like areas of solution regions, things like that. But otherwise, you need to get to practicing. So thanks for watching. Hope it helped.